90 missile cells empty. Status: Winchester. The shield is gone. 80 Japanese dive bombers scream into their final run. They think the target is defenseless. They are wrong. The Phalanx CIWS spins up. 4,500 rounds per minute. A robotic chainsaw tearing the sky apart. Tungsten penetrators vaporize 1940s aluminum in milliseconds. It is a slaughter of physics. But as the swarm thickens and the barrels glow white-hot, can a single ship survive the hate of an empire? But to understand how modern technology ended up in this hell, we need to rewind the clock. Pearl Harbor, Oahu, December 7, 1941, 0750 hours, Hawaii Aleutian Standard Time. The morning trade winds are light, 5 knots from the northeast. Visibility is unrestricted. The U.S. Pacific Fleet lies at anchor along Battleship Row, a portrait of dormant naval power. On the teak deck of the USS Arizona, the band tunes their instruments for morning colors. Brass gleams in the low tropical sun. Routine maintenance details scrub the white canvas awnings on the USS Nevada. Hatches are open to vent the smell of bunker oil and humidity. No torpedo nets are deployed. Watertight doors remain unsealed. The condition is Readiness Condition 3, peacetime. The fleet is a sleeping giant, unaware of the blade hovering over its neck. 7:52 hours. A meteorological anomaly manifests directly above the channel south of Ford Island. Barometric pressure drops precipitously, triggering headaches among the deck watch on the USS Vestal. The water surface, previously chopping with the wake of harbor tenders, flattens into an unnatural glassy mirror. Static electricity discharges across the radio rigging of the moored battleships. St. Elmo's fire dances along the gun barrels of the main batteries. The air smells of ozone and ionized metal. Space-time distorts. A spherical fracture in the atmosphere expands, refracting light into the ultraviolet spectrum. The ocean boils. With the sound of a thunderclap occurring inside a vacuum, a massive displacement of water slams against the concrete quays. The object materializes. It is not a battleship. It lacks the towering pagoda masts, the bristling casemates, and the thick belts of riveted armor plate characteristic of the era. This vessel is a monolith of angular gray geometry. The USS Arleigh Burke, DDG-51, first of her class. Displacement 8,315 tons. Length 505 feet. She sits low in the water, her hull designed for stealth, minimizing radar cross-section. To the eyes of the 1941 sailors freezing on the decks of the Arizona and the Oklahoma, she looks incomplete. No visible smokestacks, no heavy caliber turrets facing broadside, just a single 5-inch gun forward and a stark, blocky superstructure dominated by flat, hexagonal plates. Inside the Combat Information Center of the Arleigh Burke, the year is 2024, or it was seconds ago. The digital displays flicker. GPS satellite link, lost. SATCOM, lost. Link 16 Tactical Data Network, offline. The crew fights through the vertigo of transit. The Tactical Action Officer scans the Spy 1D radar feeds. The Aegis combat system reboots, its passive phased array sensors sweeping the environment instantaneously. The system is confused by the lack of digital noise. The electromagnetic spectrum is dead silent. No cell phones, no commercial air traffic. Just the analog crackle of AM radio waves. External view. The Arleigh Burke drifts motionless between the looming hulks of the battleships West Virginia and Tennessee. The contrast is absolute. 1940s industrial might versus 21st century precision engineering. The Burke's 4 General Electric LM2500 gas turbines begin their start sequence. A high-pitched whine, like a jet aircraft preparing for takeoff, cuts through the humid morning air. This is a sound unknown to the sailors of 1941. They watch in paralyzed confusion as the destroyer's navigation radars begin to spin, rapid, jerky movements compared to the lazy rotation of mechanical rangefinders. Forward deck. The Mark 45 Mod 4 127mm lightweight gun slews to starboard. The barrel elevates, the autoloader cycling a high-explosive round into the breach with a metallic clatter. Amidships, the Phalanx close-in weapon system, the white dome resembling a robotic eye, activates. Its internal Ku-band radar acquires the environment. The 6-barreled 20mm Vulcan cannon spins up for a built-in test, the dry fire buzz sounding like tearing canvas. The anomaly closes. The sky returns to blue, but the threat remains. North of Oahu, 200 miles out. The first air fleet of the Imperial Japanese Navy, a swarm of 353 aircraft inbound. Nakajima B-5N Kate torpedo bombers fly low, skimming the waves. Aichi D-3A Val dive bombers climb for altitude. Mitsubishi A-6M0 fighters weave escort patterns. Their engines drone in a synchronized mechanical harmony. The pilots check their target maps. They expect lumbering, sleeping beasts. They expect 40mm Bofors and 50 caliber machine guns. They do not expect the N-Spy 1D radar. On the Burke screens in the darkened CIC, the radar picture blooms. Hundreds of contacts. Range, closing fast. Speed, subsonic. Identification, hostile. The AEGIS system designates targets faster than the human eye can track. Fire controlman designates sectors. The Mk-41 vertical launch system cells on the foredeck and aft-deck sit flush, hiding their payload. 90 cells. Standard Missile 2s and evolved Sea Sparrows. The commander on the breach of the Burke looks out the blast-resistant windows at the wooden decks of the battleships around him. He realizes the situation. History has derailed. The rules of engagement have shifted from interception to slaughter. He orders general quarters. The klaxon screams, an electronic warble distinct from the analog bells of the surrounding fleet. The Arleigh Burke is Oscar Mike. The predator has entered the pen, but the prey is not who the Japanese think it is. Stop the clock. Freeze the frame. The roar of the radial engines hangs suspended in silence. The salt spray remains motionless in the air. On the horizon, the rising sun. In the harbor, the stars and stripes. To understand the massacre that is about to unfold, we must strip away the patriotism and look at the cold, hard engineering. This is not a battle of courage. It is a collision of eras. Analyze the aggressor. The Mitsubishi A6 M2 Type 0, Model 201. The Zero. A masterpiece of aeronautical compromise. The designer, Jiro Horikoshi, shaved every ounce of weight to achieve range and maneuverability. The airframe is constructed from T7178 Extra Super Duralumin, a zinc aluminum magnesium copper alloy. It is light. It is agile. It is also paper thin. Zoom in on the fuselage. There is no armor plating for the pilot. No heavy steel to deflect incoming fire. The pilot sits in a cockpit of glass and thin aluminum, relying entirely on the samurai spirit and a flight suit made of wool. Check the wings. Inside lie the fuel tanks. They are not self-sealing. There is no rubber bladder to close a puncture. A single incendiary round through the wing root does not just cause a leak, it vaporizes the fuel vapor. The Zero is a flying Molotov cocktail waiting for a match. Weaponry. The Zero carries two 7.7mm Type 97 machine guns in the engine cowling and two 20mm Type 99 cannons in the wings. The 20mm has a low muzzle velocity and a slow rate of fire. To score a kill, the Japanese pilot must close the distance to within 300 meters. He aims through a Type 98 optical reflector sight. He relies on his eyes. He estimates lead, gravity drop, and wind speed in his head. He is an analog warrior in an analog machine. Pan camera to the defender. USS Arleigh Burke, DDG-51. This is not a ship, it is an integrated weapon system wrapped in 9,000 tons of steel. The primary sensor, the N-SPY-1D multifunction phased array radar. Look at the hexagonal plates on the superstructure. They do not rotate, they do not blink. They emit 4 megawatts of peak power, scanning from the wavetops to the stratosphere instantaneously. The Zero pilot scans the sky and sees clouds. The SPY-1 radar scans the sky and sees math. It tracks over 100 targets simultaneously. It calculates their velocity, heading, altitude and threat level in milliseconds. The Japanese formation is not a swarm of planes to the AEGIS computer. It is a series of vectors. Now, the effector. The Mark 41 vertical launch system. Beneath the deck plates nestled in armored cells waits the RIM-66 Standard Missile 2, the SM-2 medium range. Solid fuel rocket motor, tail-controlled, speed Mach 3.5. That is over 2,600 miles per hour. Compare the kinetics. The Zero cruises at 331 miles per hour. The SM-2 covers a mile every second. The Japanese pilot has reaction times measured in seconds. The missile guidance computer corrects its flight path in microseconds. The physics are lopsided. The Zero is a biplane fighting a spaceship. Consider the engagement envelope. The Japanese attack plan relies on surprise and close-range torpedo drops. They expect flak bursts, clumsy clouds of black smoke that rely on luck to hit a plane. The Arleigh Burke does not use luck. The SM-2 utilizes semi-active radar homing. The ship's illuminator paints the target with continuous wave radar energy. The missile follows the reflection, like a shark following blood. Terminal phase physics. This is where the engineering becomes brutal. The SM-2 does not need to hit the Zero directly. It carries the Mk-125 blast fragmentation warhead. A proximity fuse detects the target's density. It detonates the warhead while still feet away. Visualization of the impact. The warhead explodes. It unleashes a radial cloud of high-velocity tungsten fragments. Imagine a shotgun blast the size of a football field. The Zero's duralumin skin offers zero resistance. The fragments shred the control cables, shatter the cylinder heads of the Sakai engine, and turn the unarmored pilot into a casualty instantly. The kinetic transfer alone snaps the lightweight wings off the fuselage. Backup systems. If a Zero somehow leaks through the missile screen, it faces the Mark 15 Phalanx CIWS, the close-in weapon system. A 20mm Vulcan Gatling gun paired with a Ku-band search and track radar. It is a robotic chainsaw. It spits depleted uranium or tungsten armor-piercing discarding sabot rounds at 4,500 rounds per minute. It tracks the incoming projectile, or plane, and creates a wall of lead that is statistically impossible to traverse. The Japanese doctrine is built on Bushido, the way of the warrior. The American doctrine aboard the Arleigh Burke is built on kill probabilities and radar cross-sections. Resume the timeline. The first wave of Kates and Zeros bangs toward the harbor. Their propellers chop the air. Their pilots adjust their goggles, expecting sleepy battleships and panicked anti-aircraft fire. Instead, they are flying into a digital kill zone. The SPY-1 radar detects the formation at 200 miles out. The Combat Information Center aboard the Burke is cool, dark, and lit by the glow of blue monitors. There is no shouting, only the quiet hum of cooling fans and the click of trackballs. The fire control officer designates the raid. The computer assigns a missile to every vector. Physics dictates the outcome. There is no maneuver a 1941 aircraft can perform to escape a Mach 3.5 interceptor. There is no jammers to confuse the radar. There is no flare to decoy the seeker. The equation is simple. Mass times acceleration meets structural fragility. The result is not a dogfight. It is an execution. 7:53 hours. The Pacific Ocean is calm, but the electromagnetic spectrum is screaming. Inside the Combat Information Center of the USS Arleigh Burke, the atmosphere is not one of panic, but of cold, conditioned air and humming cooling fans. The large screen displays illuminate the darkened room with a tactical picture. The ANSPY 1D phased array radar has already tagged and categorized the incoming anomalies. 353 tracks, range 42 nautical miles, speed 160 knots, altitude various. The classification algorithms run the data against the threat library. Propeller modulation distinct, radar cross-section consistent with Nakajima B-5N bombers and Mitsubishi A-6M fighters. Identification hostile. The tactical action officer sits at the console. His pulse is elevated, but his hands are steady. He inserts the firing key. The safety interlocks on the weapon control system disengage. He authorizes the release. The command travels through fiber optic cables at the speed of light, bypassing human hesitation. The AEGIS combat system enters auto-special mode. The ship is no longer just a vessel. It is an autonomous kill chain. Topside, the morning silence shatters. The Mark 41 vertical launch system awakens. Forward deck, cells 1 through 8. The hatches blow open. Pressurized gas ejects the canisters. Ignition. The deck is bathed in the violent orange glow of solid fuel rocket motors. Thick, white aluminum oxide smoke billows outward, instantly sucked away by the ship's forward momentum. The RIM-66 Standard missiles, SM-2 Block 3Bs, roar out of the tubes. They do not fly like airplanes. They ascend vertically, riding pillars of fire to 3,000 feet in seconds. Gravity asserts itself. The missiles execute the turnover maneuver. Thrust vector controls snap the airframes 90 degrees. They tip over, pointing their nose combs toward the northwest. The boosters burn out and separate, tumbling into the ocean. The sustainer motors ignite. The missiles accelerate to Mach 3.5. 40 miles away, Commander Mitsuo Fuchida leads the first wave. He sits in the cockpit of his Kate bomber, the canopy open to the rush of air. He scans the horizon for the sleeping giant of the US Pacific Fleet. Instead, he sees the impossible. White trails rise from the ocean surface like reverse lightning. They climb straight up, then hook sharply toward his formation. There is no sound yet, just the visual anomaly. Fuchida signals his wingman. He assumes this is a pyrotechnic display, a drill, a festive welcome for a fleet that doesn't know it is already dead. He maintains course. The SM-2s close the distance. They are semi-active radar homing projectiles. The Arleigh Burke's illuminators painted the lead Japanese aircraft with focused continuous wave radar energy. The missiles see the reflection. They adjust their fins. They calculate the intercept point. Impact. The first wave of Kate bombers does not explode. They disintegrate. The SM-2 warheads are continuous rod high explosives. Upon detonation, an expanding ring of welded steel rods slashes outward like a buzzsaw. Fuchida's wingman vanishes. One moment, a 3-man crew and a Type 91 torpedo. The next, a cloud of atomized aluminum, canvas, and aviation fuel. There is no tracer fire. No warning. Just the physics of kinetic intersection. The lead squadron of torpedo bombers is erased from the sky 30 miles out. The sheer overpressure of the detonations snaps the wings off the adjacent aircraft. The Japanese formation, tight and disciplined, flies into a wall of invisible force. Back in the CIC, the track numbers on the screen turn from red to black, then disappear. The fire control men do not cheer. They read out the battle damage assessment in monotone coordinates. Target invalidated. Illuminator free. Next target acquired. The AEGIS system manages the swarm. It prioritizes the low-flying torpedo bombers, identifying them as the highest probability of kill against the fleet in the harbor. The computer calculates launch solutions faster than the human eye can blink. The VLS cells continue to ripple fire. Whoosh, whoosh, whoosh. The magazine depth is being depleted, but the airspace is being sanitized. The Japanese formation breaks. Discipline dissolves into chaos. The Zero fighters, agile and unarmored, attempt to engage the invisible enemy. They bank, dive and climb, searching for the source of the devastation. They find nothing but empty ocean and supersonic death. The Arleigh Burke closes the range. The destroyer is now moving at flank speed, 30 plus knots, cutting a white wake through the blue water. The engagement envelope shifts. The remaining enemy aircraft have pushed within 12 miles, too close for long-range efficient missile sorting. The tactical action officer shifts focus. The 5-inch Mark 45 Mod 4 lightweight gun slews to the starboard bow. The barrel elevates to 45 degrees. The electro-optical sighting system locks onto the thermal signature of a flight of Val dive bombers. The autoloader mechanism cycles. The sound is a rhythmic mechanical clanking, felt through the deck plates, a drumbeat of industry. The gun fires. A 70-pound shell leaves the barrel at 2,600 feet per second. The casing ejects. The autoloader slams the next round into the breech. The gun fires again, and again. 20 rounds per minute. These are not standard contact rounds. They are fitted with variable time fuses, radio proximity triggers. The shells spin through the air, their internal Doppler radars sensing the reflection of the aluminum aircraft nearby. The sky ahead of the Japanese formation fills with black puffs of high explosive fragmentation. Airbursts. The steel rain shreds the fabric-covered control surfaces of the valves. Canopies shatter. Engines seize as shrapnel pierces cylinder heads. A Zero fighter, caught in the blast radius of a 5-inch shell, loses its entire tail section. The physics of flight abandon it. The aircraft tumbles uncontrollably, spiraling down into the Pacific with a terminal splash. On the bridge of the destroyer, the lookouts watch the carnage through high-powered optics. They see the fear. The Japanese pilots are looking down, searching for the battleships, but they are being engaged by a single, slender, grey hull that moves with impossible speed and fires with supernatural accuracy. The smoke from the burning wreckage stains the pristine Hawaiian morning. The Arleigh Burke maneuvers aggressively, heeling over hard as the rudder shifts. The Phalanx CIWS systems spin up, their radar domes searching for leakers, any aircraft that survived the missile and artillery screen. Fujita, his own plane riddled with shrapnel, struggles to maintain altitude. He looks down at the lone ship. It spits fire without pause. It does not maneuver like a warship of the Imperial Navy. It moves like a predator. The raid is crumbling. The coordination is gone. The radio channels are filled with screams and static. They came to awaken a sleeping giant, but they have stumbled upon a time-displaced titan. The Japanese pilots do not see technology. They see sorcery. They believe they have angered a storm god. Inside the Burke, the coffee in the mug on the sonar console barely ripples. The crew continues the work. Reload, track, fire. The objective is total airspace denial, and the morning has only just begun. The silence in the vertical launch cells is absolute. 90 missile hatches stand open, their canisters scorched and empty. The standard missiles are expended. The evolved Sea Sparrows are gone. The Burke is Winchester on guided munitions. The primary shield of the 21st century has evaporated, leaving the destroyer naked against a saturation attack. The Spy 1D radar panels continue to pulse, painting a chaotic tapestry of threats on the Combat Information Center's large screen displays. The system tracks over 80 hostile contacts inbound. These are not the distant blips of the first wave. These are Aichi D3 Eval dive bombers, and they are committed to the dive. The Japanese formation tightens. They sensed a pause in the defensive fire. The invisible hand that swatted their comrades from 10 miles away has withdrawn. The lead flight of Vals rolls over at 8,000 feet. Their fixed landing gear struts scream against the airflow as they enter an 80-degree dive. Air brakes deploy. The target is the gray, angular fortress cutting through the water below. They do not understand the technology they face, but they understand a target that has stopped shooting. The captain shifts the ship's posture. It is no longer a missile platform, it is a gunfighter. The Mach 45 Mod 4 5-inch gun on the bow traverses with hydraulic urgency. The barrel elevates to maximum engagement angle. The automated handling system in the deep magazine feeds a continuous stream of high-explosive fragmentation shells.
The breech block slides shut. The gun recoils. A rhythmic thudding begins to vibrate through the hull plates. 20 rounds per minute. The computer-controlled fire solution does not aim for direct hits. It calculates the intercept box and fills the airspace with proximity-fused steel. Black puffs of flak erupt in the path of the diving squadron. The proximity sensors on the modern shells detect the aluminum skin of the 1940s aircraft and detonate milliseconds before impact. Shrapnel tears through unarmored cockpits and canvas control surfaces. 2 valves lose their wings, tumbling into the harbor waters like broken toys. But the swarm is too thick. For every unit neutralized, 3 more press through the fragmentation screen. They drop below the effective minimum depression of the main gun. They are inside the wire. Range 2,000 meters. Closing speed 250 knots. The threat evaluation algorithm in the AEGIS combat system flashes a red priority warning. It automatically designates the leaking targets to the last line of defense. The Phalanx Block 1B close-in weapon system. Aft of the stack, the white dome of the Phalanx slews rapidly. It looks like a robotic eye searching for prey. The internal KU-band radar locks onto the leading dive bomber. The electro-optical thermal camera verifies the heat signature of the radial engine. The system requires no human input. It decides. It engages. The sound is not a rattle. It is not a machine gun. It is a continuous, tearing roar. A mechanical chainsaw ripping through the fabric of the atmosphere. The M61A1 Vulcan rotary cannon spins up to 4,500 rounds per minute. 75 rounds every second. The barrel cluster blurs into a single grey mass. A stream of tracers erupts from the mount, looking like a solid rod of laser light connecting the ship to the aircraft. The physics of the engagement are merciless. The Phalanx fires 20mm armor-piercing discarding sabot rounds, sub-caliber tungsten penetrators traveling at 3,600 feet per second. They do not just punch holes, they impart massive kinetic energy upon impact. The lead Japanese bomber flies directly into the stream. The effect is instantaneous, catastrophic disassembly. The tungsten rounds shred the propeller hub. They chew through the engine block, shattering cylinders and pistons. The rounds continue through the firewall, vaporizing the pilot station and severing the main spar of the wing. The aircraft does not fall. It disintegrates in midair. The fuel tanks ignite, turning the Val into a cloud of expanding debris and fire. The Phalanx does not pause. The servo motors whine as the gun snaps to the next target. Adjust, fire, destroy. A second bomber attempts to jink, pulling hard left. The Phalanx's closed-loop sparring system tracks the projectiles relative to the target and corrects the aim in microseconds. The stream of lead walks into the fuselage. The tail section is sawed off completely. The plane cartwheels into the sea, skipping across the water surface before exploding. Empty brass casings pour from the Phalanx ejection port like a golden waterfall, clattering onto the deck grating. The smell of burnt propellant washes over the superstructure. The roar is deafening, a relentless bzzzt that dominates the soundscape of the harbor. It is a wall of lead, a zone of absolute denial. 3 more enemy aircraft are erased from the sky in under 4 seconds. The precision is surgical. The destruction is industrial. But the Japanese pilots are veterans of the China War. They possess a fatalistic determination. They see the white dome spitting fire, and they dive toward it. A damaged Zero fighter, trailing black smoke from a shattered oil line, abandons its strafing run and commits to a collision course. The pilot is dead or incapacitated, but the machine's momentum carries it forward. The Phalanx tracks it. The gun roars. Tracers chew away the port wing. The aircraft rolls, losing lift, but its trajectory is already set. Warning alarms scream on the bridge. Collision imminent. The destroyer heels sharply to starboard.
the stabilizers fighting to keep the deck level as the hull cuts a hard turn. It is not enough to clear the angle. The Zero slams into the aft flight deck. It does not penetrate the armored hull, but the kinetic impact shakes the entire vessel. The aircraft crumples against the steel non-skid surface. The aviation fuel in its tanks atomizes and ignites. A fireball engulfs the helicopter landing zone. Burning debris washes over the stern. The twisted wreckage of the Zero slides across the deck, slamming into the safety netting. Damage Control Central lights up. Sensors detect a Class Bravo fire on the flight deck. Smoke obscures the aft camera feeds. The heat is intense enough to blister paint and threaten the sensitive electronics of the rear SPY-1D arrays. The executive officer barks orders into the sound-powered phone. Repair Locker 5 is Oscar Mike. Teams of sailors in flash gear rush toward the Inferno, dragging hoses charged with AFFF foam. They move with practiced urgency, ignoring the roar of the battle continuing above them. The ship is hurt. The pristine grey silhouette is now marred by a rising column of black, oily smoke.
The thermal signature of the burning flight deck makes the destroyer a beacon for every enemy optic in the harbor. The fire control radars flicker momentarily as power surges through the damaged grid, but the AEGIS system reroutes, isolates the fault, and stabilizes. The 5-inch gun barrel is glowing a dull, cherry red. The heat shimmer distorts the view from the bridge. The autoloader mechanism is running at the edge of its mechanical tolerance. The lubricant is cooking off, yet the gun continues to cycle. Thud. 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 The captain wipes sweat from his eyes. He does not look at the smoke rising from the stern. He looks at the tactical display. The third wave is forming up. The Phalanx is reloading. The magazine crews are sweating in the depths of the ship, hoisting shells manually to keep the feeder belts full. This is no longer a technological shooting gallery. The distance has closed. The advantage of the silicon ship is fading. It is now a brawl, steel against steel, man against machine. The Burke clears the smoke of its own wound and turns back into the fight. The tactical situation collapses for the Imperial Japanese Navy. Sortie attrition rates hit 50%, 180 aircraft neutralized. The sky above Oahu is a graveyard of aluminium and burning avgas. Flight leaders bang the Nakajimas and Mitsubishis hard to the north. The radio net crackles with panic, then resignation. The order transmits, RTB, return to base. The second wave is cancelled. The attack is aborted. The Spy-1D radar on the Arleigh Burke tracks the retreating vectors. 350 tracks reduced to 0. The threat board clears. The immediate airspace is cold. Below, the devastation is significant but survivable. Smoke columns rise from Ford Island, yet the silhouette of Battleship Row remains unbroken. The USS Arizona does not detonate. Her forward magazine remains stable. The Oklahoma lists but does not capsize. Damage control parties rush the decks, dragging hoses, foam, and seawater, suppressing the fires. The backbone of the Pacific Fleet is scorched but intact. The strategic paralysis of the US Navy has been averted. The camera pans to the source of the miracle. The USS Arleigh Burke sits low in the water, listing 7 degrees to port. The superstructure is scarred by 7.7mm machine gun fire and shrapnel from near-miss Type 91 torpedo detonations. The Mk-45 main gun droops, the barrel glowing dull red, distorted from thermal stress after firing 300 rounds in 20 minutes. The vertical launch system cells are open and empty. The Phalanx CIWS block stands silent, ammunition drums completely dry. The deck is littered with spent brass and the residue of solid rocket fuel. Inside the Combat Information Center, the displays flicker. The AEGIS system battles a catastrophic power failure. The General Electric LM2500 gas turbines whine, a mechanical death rattle struggling against a physics-defying load. The anomaly returns. Atmospheric pressure drops sharply. A sphere of blue-violet ionization expands around the hull, distorting the light. The water boils around the waterline.
The destroyer does not sink. It dissolves. The molecular bond of the ship loses cohesion with this timeline, with a final, deafening crack of displaced air, like a sonic boom occurring at zero velocity. The DDG-51 vanishes. The Pacific Ocean rushes in to fill the void where 9,000 tons of future warfare once stood. Only a slick of oil and debris remains. December 8, 1941. The smoke clears. Naval intelligence officers and salvage divers sweep the harbor. They do not find the ship. They find impossible artifacts. Divers surface holding shell casings composed of unknown polymers and discarding sabots made of tungsten alloy. Metallurgists in Washington stare at fragments of radar-absorbent composite in disbelief. Spectrographic analysis confirms these alloys do not exist in 1941 industrial science. The wreckage of the Japanese Zeros yields evidence of impossible intercepts. Fuselages shredded by proximity-fused tungsten cubes from the RIM-162 evolved Sea Sparrow missiles. The implications reach the White House. The timeline fractures. The United States Navy accelerates its R&D programs by 2 decades. The Manhattan Project gets a sister program dedicated to guidance systems and jet propulsion. The age of the battleship ends overnight. The age of the missile begins before the war even turns. By 1944, the U.S. fleet deploys primitive guided munitions and radar systems reverse-engineered from the Burke's leftovers. The Pacific War concludes not with a grind, but with a technological slaughter. The Arleigh Burke is listed as missing in action, its crew lost to the mist of time, but the mission is a total success. History has been rewritten in fire and steel.